All right, lesson 8.6, we go on into the world of estimating square roots, and we're going to use those estimations to solve problems. Now, the one thing that we have to realize is we have, in our world of square roots, we have the perfect squares, and then we have a lot of numbers that are not perfect squares. So, for example, here, here we have a basic list of a few of the perfect squares. If I take the square root of 1, I get 1 and negative 1. Okay, square root of 4 is 2 and negative 2. And again, right now, I guess I should probably include my positives and negatives. Positive and negative 3 here, positive and negative 4 here, and so on, right? These are all numbers that have really nice, neat, rounded off, whole number or integer square roots, okay? Square root of 49 is positive and negative 7. And this continues, okay, because we have 8. 8 times 8 is 64. We have 9. 9 times 9 is 81, and so on. Okay, so this list here does not stop at 49. It continues. All right, the problem is we have a lot of numbers that fall in between. Square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, square root of 15 would fall between square root of 9 and 16, or all of the square roots between 16 and 25. And then we even get to numbers that have decimals, like the square root of 16.2, for example. Okay? And that value is some really ugly thing. And so the thing that we have to realize is we have a lot of numbers that do not have perfect square roots. Square root of 43, for example. Okay? And so we have to have a way in order to deal with them and have some idea of what they are. Now, the first thing is a square root is not divided by 2. So that's the one thing that you have to get out of your mind. This is not 15. Okay? Square root of 15 or square root of 30 is not 15. We do not just divide by 2. What number times itself is 30? And in this particular case, we're going to have to do some estimations. Now, in this case, all we're going to do is we are going to just begin with finding the square root of 30 is between what two whole numbers. We are not going to approximate it completely. Okay? So what I'm going to do, and if you need your chart here, go ahead and use it. But remember that this chart does not have every one. There are more values off to the right that are not on the chart, which you might want to add those numbers to your chart. Again, 8 is 64, 81 and 9, 110, and so on. You probably want to have those things. So in this particular case, all I'm going to do is identify the perfect square on either side of my number. So the perfect square below is 25. Okay? The perfect square above is 36. So now, the square root of 25 is 5. The square root of 36 is 6. So what I know at this particular point is the square root of 30 will fall somewhere between 5 and 6. Okay, we will get to the approximate decimal stuff in a few moments. Right now, all I know is the square root of 30 falls between between 5 and 6. And that's where we're going to leave it at this particular moment. Okay? The square root of 67 falls between what two whole numbers? Well, okay, and again, if I go to my chart, but oh, wait a second, doesn't fall on my chart, which means I have to know what those perfect squares above are. Okay? So the next perfect square on the chart would have been 64, because the square root of 64 is 8. Okay? After 8 is 9. 9 times 9 is 81. So the square root of 67 falls between the square root of 64, the square root of 81. So I now know that my value here, the square root of 67, is 8 point something. Okay? Not sure what that decimal value is at this particular point, but we know that this value, the square root of 67, will fall between 8 and 9. So that's the first step. Okay, so now, we take it the next step, and we're going to go ahead and we are going to try to find an approximate decimal value for the square root of 43. Okay? So now, we're going to do what we did before. We're going to say, okay, we are taking the square root of 43, the approximate square root of 43. Now we want to try to find ourselves an actual decimal value. So just like we were doing before, what are the perfect squares that surround 43? Well, I know the square root of 49 is just above. 7 times 7 is 49. 36 is below, which that will give me 6. So I now know right now that this is going to be 43 is 6 point something. We are now going to try to figure out what that something is. And I'm going to do to try to figure that out is go, okay, how far apart are 36 and 43? Well, if I were to put them on the number line, those would be 7 units apart. Okay? 43 and 49 are 6 units apart. Now, if they were equal, if somehow this were 7 and this were 7, our value we would know would be 6.5, because that would put our value halfway in between these two. Okay? But it's not exactly, in this case, it's not exactly in the middle. We are very slightly closer to 49. So my answer has to be slightly closer to 7. So in this particular case, I'm going to call it 6.6, and it's good enough for what we're doing. So the approximate value of the square root of 43 is around 6.6. Again, it's slightly closer to 49 than it is 36, so I've got to go slightly closer to 7 than I do 6. All right, let's try another one. The square root of 200. Wow. All right, well, let's think of our values. 10 times 10 would give us 100. Right? Square root of 100. Can we get closer? 11 times 11 would be 121. 12 times 12 would be 144. 13 times 13 is 169. You know what? I'm going to get rid of, because I'm just getting there. 169 would be 13 times 13. 14 times 14 is 196. Still not there. I guess I can get rid of this. 196, which, by the way, this is why you may want to continue that chart. Again, let me flip back to the chart. You'll notice I'm hitting perfect squares out here that are not on the chart. So maybe you want to continue the chart so that you don't have to do it like I'm doing right now. I'm just doing sort of the guess and check method. So that was 14 times 14. Okay, 15 times 15 would be 225. All right, so 225, that would be 15. Sorry, I didn't write down my 14 over here. So I now know my value, my square root of 200 is going to be between 14 and 15. 14 point something. So, change some colors here. How far apart are 196 and 200? Well, that's just 4 units. 200 to 225 is 25 units. So we definitely know now that my value here has got to be much closer to 14 than it is 15, because these two values are not even close to being the same. Again, if these were close to being one another, then we would know that we're somewhere close to the middle. But in this particular case, we're not. All right, so because this is, if this were like a 1 or something, I would go 14.1 or 14.2. I'm going to go at about 14.2. I think that's a reasonable estimate to get us pretty close. Again, much closer to 14 than 15. And it's not anywhere, it's not even close to the middle, because these two numbers would have to be almost identical to be in the middle. So I definitely need to be 14.1, 14.2, both fine estimates. All right, your turn. Obviously, I am available for help. Come see me when you have those questions.